So number 9, since we're looking at the function f of x equals 1 over x, we're also looking at x equals 1, and we're looking at x equals 2, and we're looking at the x-axis. So we're taking all 4 of those things and finding the region. So 1 over x just looks like this, and x equals 1, and x equals 2, and then we're going to revolve around x equals 3, and we also have the x-axis down here. So the region that we're looking at here is this one. And if we're revolving around x equals 3, that means that we've got to slice it horizontally because we're revolving around a vertical axis. So we're going to end up with like this other little chunk of this thing over here and sort of like this 3-dimensional space here where we've got like, that's revolving around. Yeah, everybody good with that? Conceptually good with what it's sort of looking like?
Yeah.
All right. Wonderful. Okay. So since we've revolved around a vertical axis, we're going to slice it horizontally, which means we're going to have a thickness of dy, which means that everything's going to have to be done in terms of y. And we need to note something as we're starting this one. First off, the outer radius, no matter what, the outer radius is always going to come from this vertical line x equals 1, right? That's x equals 1. The distance from x equals 1 to x equals 3, that is always the outer radius of this thing, right? So our outer radius is 3 minus 1, or 2. Everybody okay with that?
Yes.
Okay. Now, the issue that pops up here is that the inner radius sometimes is defined by this vertical line, but it's also sometimes defined by the curve 1 over x. So from here to here, it's defined by x equals 2. But continuing up the rest of the way, the inner radius is defined by 1 over x. Does everybody see that?
Yeah.
Okay, so I'm going to have 2 different inner radii, and that means that I'm going to have to do 2 different integrals. One from the bottom up to this point, and then one from that point up to the top. Conceptually, is that okay with everybody, since the inner radius changes? I hope. So what's our inner radius down here on this vertical line piece? Well, it's just the distance from x equals 2 to x equals 3. That's just 1 unit, isn't it? And we'll say that's the case from y equals 0 to y equals, well, what is this point where 1 over x intersects with x equals 2? That'd be y equals 1/2, wouldn't it? If x is 2, then y is 1/2. Yes, no, maybe?
Yes.
All right, good. And then our inner radius up here where we're talking about the green piece of it, well, that inner radius, we're going to have to look at how far over we've gone. Well, how far over do we go from the y-axis? That's x. And the radius is the rest of that. Do y'all agree with that? So that radius ought to be the full distance, 3 minus x. And what is x equal to? X is equal to 1 over y. So we have an inner radius of 3 minus 1 over y from y equals 1/2 to y equals 1. Good or no?
Good.
Wonderful. Okay, so now we're just going to set this up into two different integrals. One will be pi times the integral from 0 to 1/2 of that outer radius squared minus the inner radius squared dy. And then we'll add to that pi times another integral from 1/2 to 1 of the other, well, the same outer radius, because that doesn't change, squared minus the inner radius squared dy. And that's the setup for this.
So we're dealing with the square washer separate from like the quarter ramp washer.
Correct. Yes. Solely because the rightmost piece of this region changes from 1/x to x equals 2 during some of these y values. Like at y equals 1/2, it changes from one to the other, the right bound of the region. Does that make sense?
Yes.
Great. So I don't know if we want to evaluate this out, we could pi times the integral from 0 to 1/2 of 3 dy, and then plus pi times the integral from 1/2 to 1. Let's see, this one becomes, let's see, 3 minus 1/y squared is going to give me a constant of a 9, right? So I'm going to have a 4 minus a 9, so I'm going to have a -5 there. And then I'm going to have, this should become a minus 6/y, and then minus that, so that should become a plus 6/y. And then the minus 1/y times minus 1/y should be plus 1/y squared, and then there's a minus in front of it, so that should be a minus 1/y squared dy. And now we should be able to integrate. So we end up with pi times 3y from 0 to 1/2 minus pi times -5y plus 6 natural log absolute value y plus 1/y from 1/2 to 1. And then from there, it's just arithmetic. I don't know if you guys want me to do the arithmetic or.
Mr. Bachelor?
Yeah.
Why did it change from adding the integrals to subtracting?
It shouldn't have. Thanks. I don't know why I changed that to a minus. I shouldn't have. You guys want me to evaluate that, or you guys feel okay about that now?
I think we're good.
Okay. Wonderfully. I mean, that's just arithmetic. So, yeah, you have 3 pi over 2 there, and you end up with like, a bunch of numbers. Remember that the natural log of 1 is 0, so that's going to cancel out that term nicely when you plug in the 1. Yeah. So. Cool. Dot, 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 dot. Some answer. I don't know what it is, but some answer. All right. Number 10, I believe number 10 gave us the same region. Is that right? Except this time we're going to revolve that region around the line y equals -3. So, same region, x equals 1, x equals 2, y equals 1/x, going around y equals -3. So this time, since we're going around a horizontal axis, we're going to slice it vertically, and we're going to end up doing it in terms of x. And it's going to be pi times an integral. And this time, since we're doing it in terms of x, it's just going to be from 1 to 2. And we don't have to separate this one into multiple integrals, because from x equals 1 to x equals 2, the bottom part of the region is always the x-axis, and the top part of the region is always 1/x. It doesn't ever change. So what is our outer radius and our inner radius? Our inner radius ought to just be the distance from the x-axis to y equals -3. So our inner radius ought to be 3. And our outer radius ought to be the distance from the function, let's do a different color, the difference from the function down to y equals -3. So that's 3 plus 1/x. Everybody okay with that?
Yeah.
Okay. So now it's just outer radius squared, so 3 plus 1 over x squared minus 3 squared dx. And we'll simplify our integrand. So pi times the integral from 1 to 2. 3 plus 1 over x gives you a 9 as the first term, which will cancel with this, minus 9. And then we'll just have a 6 over x and a 1 over x squared. And that gives us pi times 6 natural log absolute value of x minus 1 over x. If you integrate both those, just using the rule for 1 over x and the rule for, power rule there. And we'll evaluate it from 1 to 2. And we end up with pi times 6 ln 2 minus a half minus 6 ln 1 minus 1. And minus a half minus a negative 1 will become a plus a half. And 6 ln 1 is 0. So we end up with pi times 6 ln 2 plus 1/2. Everybody okay with that? Any questions on that one? Everyone's good? Any other questions? Let's see, who is this? Serena, you asked about that. And then number 10. You good with that one, Serena?
Yes, it's good now.
Okay, just making sure. And all 7 of you that asked about number 9, you're all okay with number 9 now? Wonderful. All right, anybody have any other questions? Or if not, we're going to start the quiz. Oh yeah, I forgot. So Ronick, and I think is there anybody else that's from period 6 that's going to be taking the quiz in this period? I know Ronick, but anybody else? Yeah, I told somebody else they could do that too. Maybe not. Anyway, I'll just throw the link up into the chat here also. And then if you're in period 6, just post your work in the period 6 quiz in Google Classroom, obviously. But I'll have I won't have a link up in there for an assignment yet because it's a different quiz for period 6. Just make sure, Ronick, that you write "This is the period 4 quiz" at the top of your paper so that I remember when I'm grading it that I'm grading the period 4 quiz for you.
Okay, thank you.
Yep. All right, cool. That seems good.